Hello, welcome. This is me getting into the meta language, which is a multi-paradigm glue language for open um, for AGI, made by Ben Goertzel and his collaborators. So let's see what this how this will turn out. So this has a lot of functional and sort of logic, relational programming things, and I think it's quite unique. It's a metagraph rewriter, and it is non-deterministic as well. So there's multiple outcomes for everything you do. So um, let's go to learn and go through this documentation that they have. Table of contents, main concepts, basics evaluation, recursion and control, free variables, and non-determinism again recursively. All right, all right. Let's go to main concepts. On the left, I have the meta REPL running. So I type something like, I think you say eval plus is a symbol and then 1, 2. Yeah, that for example returns something. Let's see. Main concepts, atoms and knowledge graphs. Meta with the T's in capital Metta Type Talk is a multi-paradigm language for declarative and functional computations over knowledge metagraphs. Every meta program lives inside of a particular atom space or just space if you don't insist on a particular internal representation. Atom space is a part of the OpenCog Hyperon software ecosystem, and it is essentially a knowledge database with the associated query engine to fetch and manipulate that knowledge. All right. It is a knowledge database, the Atom Space. Also, Atom Space is a separate software, I think. Um, I'm guessing that you have a Atom Space, which is sort of the set of defined things or something like that. And then Atom Space is, I think, also a software with a knowledge database and a query engine. Okay. So I'm guessing that is sort of provided for us if we hook into this OpenCog software ecosystem, I suppose. Yeah, let's see. Meta programs contain both factual knowledge and rules or functional code to perform reasoning on knowledge, including programs themselves, making the language fully self-reflective, like Lisp or something, or Smalltalk. I guess Smalltalk. This is Smalltalk self-reflective, or not? But it's certainly like Lisp. It has basically sort of macros, kind of taking code as input to your program and then doing something. One can draw an analogy with Prolog, which programs can also be considered as a knowledge-based content, but with less introspective and more restrictive representation. Okay, I guess they say that Prolog has a more restrictive representation and is less introspective. All right. Let's see. In an atom space, an atom is a fundamental building block of all the data. In the context of graph representation, an atom can be either a node or a link. In an atom space, as metagraph, links can connect not only nodes, but other links. That is, they connect atoms and they can connect any number of atoms, in contrast to ordinary graphs. Yeah, in a graph, you have nodes and links, and you always point to a node, but in a metagraph, I suppose you can point to links, something. In Meta, as a programming language, atoms play the role of terms. I find this kind of funny, like expressing a language in terms of something. I don't know, this is kind of cute. The terms. So it's literally like the things that we say. I guess these things are atoms or something. Um, no, the language is made from atoms somehow. In the context of AI, atoms can represent anything from objects, concepts to processes, functions, or relationships. This enables the creation of rich, complex models of knowledge and reasoning. yeah, kind of saying we want to basically make a glue for all kinds of different paradigms a little bit, something. Atom kinds and types. There are 4 kinds of atoms in matter. Symbol, which represents some idea or concept. 2 symbols having the same name are considered equal and represent the same concepts. Names of symbols can be arbitrary strings. Nearly anything can be a symbol. Um, this is basically a scheme kind of thing that you put question marks. That would be a Lispy thing. This is math. If I say describe char, if I say describe char, I see Emacs calls this character neither greater than nor equal to. Neither greater than nor equal to. Okay. Yeah, I guess it makes sense. This is a symbol. Yeah. Okay. Either way, let's keep going. Yeah, you can also put Unicode. Which is, I think, maybe this is the next thing happening in programming languages, that we start programming with emojis, or we have emojis. I think, yeah, if I say foo, and then I say ox, what does that do? I guess this evaluates the tuple foo ox or something. Yeah, something like that. Yeah. Okay, let's keep going, because right now I don't do anything but having symbols. Expressions can encapsulate other atoms, including other expressions. Basic meta syntax is scheme-like, so you have tuples, function, arguments. Here implies, and then some nested thing and so forth, so it's trees of lists or tuples. Variable, which used to create patterns, expressions with variables. Such patterns can be matched against other atoms to assign some specific binding to their variables. Variables are syntactically distinguished by a leading dollar, e.g., $x, $underscore, $my argument. All right. So this is something that you would also have in. I know I'm coming from Clojure, so I know data log, and in data log you have also variables that is they're basically allowed to be bound with something that the match engine is basically finding a binding for. So that's the variable in sort of in this context of this matching thing. It's something that is allowed to be bound by something else. To convert a symbol into a variable. Okay, so dollar makes a symbol into a variable. Okay, patterns could be parent x y. Okay, this is now a pattern. So a pattern is an expression with variables, I suppose. Implies human. There's a variable. There are variables, and some nested things with variables, or any other symbolic expression with variables. Such patterns get meaning when they are matched against expressions in the atom space. Okay. Grounded, which represents subsymbolic data in the atom space. Yeah, which I find a very cute idea. Makes it quite clear that we have a symbolic layer where we express things in types in terms of meta, and the subsymbolic layer, which can be Python or pointers to memory, I suppose, or like arrays in memory or something like that. Um, I find this cool. I never encountered subsymbolic sort of in this way, but um, this is actually very clear. Um, Yeah, okay. Let's keep going. It may contain any binary object, for example, operation, including deep neural networks. Yeah, so can point to some Python thing. If we treat Python as a subsymbolic thing, then basically you can say here's a symbol in meta and it represents this neural net. So somebody else, maybe they know how to make a process using this neural net, and but we have a name for it, that basically a pointer pointing to something subsymbolic. Collection or value. Grounded value type creators can define custom type, execution, and matching logic for their value. So this is kind of interesting now that basically the way to extend the language is by saying, for example, the matching logic as well or something like that. So that becomes quite interesting, I think. But let's see. There are some grounded atoms in the standard library to deal with numbers or strings. Plus, so this plus is an expression composed of the grounded atom plus, which refers to an arithmetic operation. So that is basically, I'm guessing, implemented in the standard lib. It's implemented in the standard lib. Yeah. So if I go to hyperone experimental, right? Then they define somewhere this plus. If I go to the, I wonder, interpreter minimal, meta interpreter minimal, old interpreter. That was the expression variable. Okay, yeah, the expression. This is everything with parents. A variable that is something with a dollar sign, and a pattern is an expression with a dollar sign. Grounded are basically the primitives. Well, they are the primitives that are implemented in the standard lib, like plus and one or one, two, and so forth. Yeah, they're basically implemented in Rust if you're running a Rust meta interpreter. But yeah, like the point is that you can add, for example, like PyTorch tensors or something like that as grounded symbols. I think this is, as far as I understand, the point of this. Symbol variable grounded can be considered as nodes, while expression can be considered as a generalized link. This interpretation of atoms plays an important role in meta applications and Hyperon as a cognitive architecture, but it's not essential for understanding meta as a programming language. Yeah, so I looked at the paper Meta. This is the metagraph rewriter, and this metagraph stuff. But yeah, this is good to know that we don't need to care that much. Meta has optional typing, which is close enough to gradual dependent types, although with some peculiarities. Percent, undefined percent is used for untyped expressions. Okay. While other types are represented as custom symbols and expressions. Symbol variable grounded and expression are meta types, which can be used to analyze meta programs by themselves. They are subtypes of atom. Okay, everything is everything has the type atom, I suppose, except things that are undefined. For untyped expressions. Okay. And then gradual dependent. Dependent means it depends on the value, so you can talk about the value of a type and it changes the type. Something like that. And gradual also has a specific meaning. I think that type grows with different kinds of values as well, or something like that. Actually, what is gradual typing? Gradual typing is in between static and dynamic. Some variables and expressions may be given types, and the correctness is checked at compile time, which is static typing, and some expressions may be left untyped, and eventual type errors are reported at runtime. That is dynamic typing, but you can mix it, so that's gradual. Gradual typing allows software developers to choose either type paradigm as appropriate from within a single language. In many cases, gradual typing is added to an existing dynamic language, creating a derived language, allowing but not requiring static typing to be used. In some cases, a language uses gradual typing from the start. Yeah, it's kind of like these cutting edge type systems. TypeScript is also TypeScript is a gradual typed language because you can say any, so it's a dynamic type, and you can also say a type. Typed closure is also basically making a alternative static type thing that is optional. Okay. So you can choose if it's typed, and then it's dependent. So you can say something about the values of a type, and then it changes what the type is or something like that. At runtime, I think dependent is always at runtime, I think. A dependent type is a type whose definition depends on a value. It is an overlapping feature of type theory and type systems. In intuitionistic type theory, damn, dependent types are used to encode logic's quantifiers like for all, and there exists. What exactly does this mean? I'm not entirely sure. Logic quantifiers. There exists. Okay, I guess that means that it is something exists for sure. Something is not is there at least once, or naja, something like that. In functional programming languages like Agda, ATS, Cog, F star. I didn't know F star. Epigram, Idris, and Lean dependent types help reduce bugs by enabling the program to assign types that further restrain a set of possible implementations. Yes, it's like saying it's an integer, but it's between 0 and 10 or something. For example, length. But yeah, let's see. Special symbols. There's a small number of built-in symbols which determine how metaprogram will be evaluated. Equality symbol defines evaluation rules for expressions and can be read as can be as evaluated as or can be reduced to. Okay. Colon for type. Arrow symbol. Type restrictions for evaluable expressions. Okay, so this is I guess this arrow is going a little bit into this dependent type kind of thing, because you have type restrictions or something. You say that this is allowed to be a range of types or something like that. I think you can also say something like if A is type A, then if X is type A, then Y is type B, or things like that. These atoms are of symbol metatype and do not refer to a particular binary objects, unlike rounded atoms, but they are processed by the interpreter in a special way. Okay, so that is like sort of very special. These three ones are the special forms, basically, that if the interpreter looks at them or something. Colon, arrow symbol. Check if function type is applicable. Arrow symbol. Is meta type. Atom type tone. Symbol variable expression grounded. Ah yeah. Yeah, I wonder if somewhere there's an if statement where it says this is an equality. As direct equality. Interpret atom evaluate variable via call in direct equality. There's a test. Let query. Huh. Equal symbol. Equal symbol. I think I see here these special types. There's also another one. Colon greater. And this equal symbol, match or blood query. Oh, it's not used so much. Okay, let's go further. Basic evaluation. Meta program. Programs in Meta consist of a number of atoms, mostly expressions, but individual symbols or grounded atoms can also be put there. A meta script is a textual representation of the program. Meta script is a textual representation of the program, which is passed atom by atom and put into a program space. So the whole script is put into the space, or the atoms or something. Or I guess all the scripts are put into the space or something. In particular, binary objects wrapped into grounded atoms are constructed from their textual representation in the course of parsing. For example, plus and 1.05 will be turned into grounded atoms containing corresponding operation and value. Yes, okay. So I go through the syntax tree and I'm here, and this I can imagine that it's parsing it, but it's basically replacing it. It turns it into this operation. So I'm guessing now that I have an AST or something where this is the operation plus, and then these are the grounded symbols 1 and 2. Grounded atoms and their textual representations is not part of the core meta language, but is defined in modules, both built-in and custom. How modules and grounded atoms are introduced is discussion in our tutorial. This is when I build my own grounded atoms, I guess. Modules. If a programmer wants some atom to be evaluated immediately instead of adding it to the space, that's what this exclamation mark is. So, exclamation mark should be put before it. The result of evaluation will not be added to the space. So, but will be included into the output result of the whole program. So I can write a script and I can write exclamation marks, and then it's an output. At the wrapper, I type exclamation mark. I wonder, what does this say? So this is the expression foo. Yeah. Meta scripts can also have comments starting with colon, which will be ignored by the parser. In the following program, the first two atoms will be added to the program space. Yes, so if you just type a hello, now hello is in the program space. Okay, then I type hello world as tuple, and that's in the program space. While the next two expressions will be immediately evaluated and appear in the output. Yeah, okay, so I already did this. 1, 2. Exclamation mark hi there. And this is the list. This is the expression hi there. And hi there is not in this program space now because of the exclamation mark. If an expression starts with a grounded atom containing an operation, this operation is executed on the other elements of the tuple acting as its arguments. This is of course evaluated to 3. So that is happening in Rust, where we say plus 1 to. At the same time, hi there is evaluated to itself, because hi is not a grounded operation. Yes. But just a custom symbol. It acts similar to a data constructor in Haskell, but more on this in another tutorial. Yeah, okay. Let us consider how to do computations over symbolic expressions in Metta. Yeah, okay. So how do I program with this? Because no, it just returns hi there, right? For a symbolic expression in Metta to be evaluated into something different from itself, an equality should be defined. Equality expressions work similar to function definitions in other languages. There's a number of important differences. Let us consider a few examples. Okay, so now I'm gonna define equal. So equal says this can be reduced to, or this can be evaluated as. So I say age can be evaluated as hello world. So this is sort of this equality in the atom space now. If I say evaluate the list age, is a little bit like a function call. So this looks basically like a function call in Clojure or something like that. So far, if I go to Clojure scratch buffer and I would type basically the same thing, then it would have been def a function called age that doesn't take any arguments and that returns a list of hello world or something like that. That would have been the same thing, and then I evaluate like this, so it looks almost the same, except that here there's more than one outcome, and yeah, this equal sign was used, but this would be the interesting difference now. So let's see. Some functions can accept only specific values of this argument of its argument. So yeah, okay. You can basically put arguments there now. When this argument is passed, the right-hand side of the corresponding equalities return. So basically, we are sort of constraining this. So I say equal only a, and then a. So I need an a. I say that the left side of this equality is called only a, in parentheses. So a is this is like saying that this expression is equal to the expression input a is accepted. Yeah, and then of course you already see that I can say only a. Okay, this is trivial, right? Okay, I said that only a can be evaluated as input a is accepted. Okay, but this is not being evaluated to anything, because it doesn't match this a. That is the symbolic expression, and I suppose I have the suspicion that I can say here any symbol, and if I put this variable thing here, no, it's probably anything. So if I say any symbol and I evaluate this, then I get, yeah, so that basically substitutes it, and then probably like this. So this is input ABC is accepted. So that would have been the difference, that you have a variable here. But because if you have a symbol there, yeah, I guess now the cool thing, this already is sort of like doing something, because it's checking if A is A. So then it returns this. So it's already not completely useless. Note that only B is not reduced. In Metta, functions should not be total. Functions should not be total. So the one that I did here is actually anti-pattern or something, I suppose, because I'm taking any input and I return an output. So no matter what the input is, I return an output. Because total, as far if I remember correctly, a total function means that basically all inputs have defined output. Is a function that is defined for every possible input in its domain and always returns a valid output in its range. X plus 1 is total because for all integers I return some valid integer. Okay, but this is interesting. The meta functions should not be total. You should always narrow something down or something like that. Like that is interesting. You shouldn't do something like this. What I did here, that any input is sort of allowed or something like that. And there's no hard boundary between a function and a data constructor. For example, consider this program. Respond me. Okay. Los. Exclamation mark, respond me. That of course responds this expression, yes. Now I say equal respond me. Okay, I will respond. Okay, yeah, if I see this expression, I will do this. It's the same as we already had. Yeah, we already had this. This is the same as the symbol A situation. The first respond me will remain unchanged, while the second one will be transformed. Yeah. Functions can have variable parameters, just like in other languages. Yes, okay. So here... But isn't this a total function now? Duplicate $x and now $x $x. Yeah, this for example, duplicate a returns to a. Yeah, okay. Here's a number, same thing. The passed arguments replace the corresponding variables in the right-hand part of the equality. Its arguments can be expressions with some structure. Okay, equal swap pair $x $y. Yeah, so now I take basically a pair as input, and my function is called swap, and then I return a pair $y $x. Okay, now I've swapped the pair. Okay, so swap a pair A B and I get BA. Yeah, it's kind of fascinating that they are going to build a whole language now out of this stuff like this. I feel like we already saw the bottom stuff. Yeah, okay. I think I go a little bit quicker now. Yes, you could make something like this. Coulda returns the second element in a cons, and then cons coulda that outputs cons be. Yeah, okay. I mean, I can copy this and paste it in once, see it. Stuff like this. But it is more general because the structure of patterns can be arbitrary. In particular, patterns can contain the same variable encountered multiple times. Okay. No, it already becomes a little bit more interesting. Yeah, so because so far I could have implemented this in terms of closure function still, more or less. Duplicate for sure. Duplicate would have been easy. That's just x, and then it is a vector xx, for example, pair xx. So duplicate duplicate a would have been aa or something. Okay. And swap this already. yeah, would have actually maybe been or would maybe have been a multi-method, because pair, right? Um, yeah, but you could also say this. Yeah, yeah, it's already kind of like not so easy anymore. I could have said this, and then if that is called pair, then I would have returned. Um, yeah, then I would have returned nth object 1 and 2 swapped like this, and yeah, else you would maybe return nil, for example. So swap pair, maybe like this, AB arity exception. How does this work? BA, this would return BA. Also not swap. Oops, that was the wrong function. Yeah, this would also still kind of like be more or less easy to say. Yeah, no, if you say 10 here, maybe it should return. Yeah, this is already not so easy. It would already be kind of like more something like this or something. That I need to check the type, and why would this not work? Need to debug. I can't. I seek. So, oops. I wanted that one with the question mark, I guess. Okay, so this would more or less be this swap function, and it wouldn't be. I mean, of course, we would have multi methods and so forth, but yeah, no. Okay, this is just a play on the same concepts. That's not so interesting. And then, but yeah, now it becomes now it really becomes interesting. Yeah, now I really start needing something like this closure core match thing. That I use the same variable twice. So I say check x y x, and that is now x and y. So that says that the only thing that will evaluate evaluate something new. Yeah, it basically says does the input have this pattern of relationships? Kind of, it already says this kind of like, yeah, that is already something that is yeah, you need some kind of relational system a little bit, or something like yeah, something like data log or something like that to say things like this. But yeah, so here it is like very at the bottom of the language, already built in kind of. So yeah, let's see. This is for sure interesting. Yeah. So you say sort of what is the structure of my input? Okay. Functions can have multiple non-deterministic results. Yeah, this is the next thing that is special here. So I say bin I say bin is equal, reduces to 0, but now I go and I say bin is equal or reduces to 1, and it just works. And it's not overridden, but it's actually both. It's just both. So if I say, yeah, this is funny now, right? If I say 10 and then here bin eval is, right? That should be plus 0, so 10, and then plus 1, so 11. So it should be 10 and 11 both. Yeah, and that is I think this is a very interesting property. I'm a fan of non-deterministic evaluation. That is kind of like one of the reasons why I come to this language, because I'm into sort of things that are a little bit like quantum-inspired computing or something like that, in a classical domain. I think that is a very interesting thing to look at. So here we are. Note that equations for functions are not mutually exclusive, and the following code will output two results, not only catched in the last case. Okay, say equal f special value catched. So that will of course say f special value, then it returns catched. Now equal f x is x. So now I'm doing some non-deterministic stuff where special value. Yeah, I see what they mean. That now I get a. Yes, I get a. It basically only went into this branch of the world or something like that. But if I say f special value, then both will happen. It's the conjunction, I think it's called. No, it's called the disjunction. Yeah. Yeah, this was the disjunction. Yeah. Special value. It went into the disjunction of these. Most importantly, variables can also be passed when calling a function. Unlike imperative or functional programming languages, this will result in returning the right-hand sides of equalities. What? Okay, I'm gonna type what they say. Equal brother Mike. So if the input is brother Mike, then it reduces to Tom. If the input is brother Sam, then it reduces to Bob. Okay. So I'm kind of saying some relationships a little bit or something like that. Brother Sam becomes Bob. Yeah, okay. Now exclamation mark brother X. Oh. Oh, this is. Oh. Oh, because these things are in the atom space or something. Oh. What? Ah. No, it goes into all possible brother things now. The other way around, like X says, so because I kind of say to the evaluator, yeah, X is sort of like unallocated, is a free variable or something like that, I think it's called. And then you can do anything with the atom space and match it or something like that, reduce it, what I say, and see what you come up with. And then it says that, oh, I see that there's a brother Sam equality thing to Bob, and then Bob is an outcome. Damn, what the hell? Okay, so this is yeah, our program basically sort of being a data log kind of query engine by itself. Okay, so now I say brother dollar X. So this is Bob and Sam now or something. Is the brother of is the brother of dollar X. What will this do? There's one sec. X is allowed to be Mike and Sam. So does this reduce to Tom or something like that? But yeah, it will just not work because you see that if X is Mike, then if X is Mike, then this thing is Tom, and then it will say is the brother Tom. But this says Mike. So but X is X, we say either X is Mike or Tom, and but like we only say a single X here, so you see that there's only one variable, but there's sort of two brothers that we talk about, so that this will just return nothing, I think. Or what will it do now? It's not lost. The binding for X is not lost. Okay, what does this do? Bob is the brother Sam. Tom is the brother Mike. Okay, I was wrong. What is that? Brother X. Okay, that is allowed to become. Ah. This was not correct what I was thinking. It's actually, it's like it's fresh here or what? Is the brother Sam? Bob is the brother Sam. So we say X is. So okay. Now I get it. Okay, so you say X is Sam. So then it goes into here, kind of. The whole thing evaluates to Bob. So we say you Bob. So okay. True. I didn't see that. It's you can. It's not true what I said. Yeah, that X is allowed to be Sam, and then the sentence still makes sense. Yeah, that would say that Bob is the brother, and then Sam. I'm missing an off there. Fucking hell. Bob is the brother of Sam. Okay. Yeah. So here now I'm on video figuring out the this language. Good luck. See you soon. Code with heart. This was part 1 of multiple.